polar curves r equals 2 sine of 3 theta and r equals 5 sine of 3 theta. Okay, well, if we're going to find the area between those, we're going to need to know the bounds, and it's pretty hard to know the bounds. Oops. It's pretty hard to know the bounds if you don't have a graph to see where what's happening with the angles. So neither one of these are going to be super easy to graph. So again, I'm going to do kind of the quick version. The slow version is make more points. The more points you plug in, the more points you can plot on the graph, the more points you have on your graph, the better you're going to feel about having it graphed correctly. Now, me personally, I can see that both of these, since this is an odd number, I know that there's 3 petals. And so really, as soon as I figure out where one petal is, I know the other 2 are going to be equally spaced out. It's not like 2 petals are going to be right next to each other and the third petal's way away from them. So I'm going to take my time and do real carefully with this one, and then it's not going to take me much time to adjust for that one. So I could plug in 0 and get 0. I don't know. You can just start plugging in random stuff. There's nothing wrong with that. Plug in pi over 6. You get 2. So that would be about right there. Now, I kind of brought this up in a previous question, but what's the biggest value that sine can ever be? So if the biggest I can make this be is 1 times 2, the biggest petal is going to go out as far as 2, right? So this is really like the tip of the petal. So I don't know. That helps me a lot. I could say this was 0. The angle barely moved, and it went up to 2. And so I'm guessing if I barely move it that much again, if this is 0 to pi over 6, I feel like adding another pi over 6 is probably going to take it back to 0. It's probably going to close this petal. So I'll plug it in and test. Sine of 3 times pi over 12 would be the sine of pi over 4, which is not what I wanted. Yeah, that's not what I wanted. So my guess was off. That's why I say you should always test it. I can see on my paper, though, that I picked pi over 3 at some point. So again, it may not jump out at you right away, but pi over 3 times 3 would be pi. The sine of pi is 0. So I believe, oh, that makes sense. My logic was good. My approach was bad. I said if this was 0 radians and this is pi over 6 radians, it's probably another pi over 6 to close the petal. But I didn't do 2 pi over 6, which would be 1 pi over 3. I did pi over 12, and that's I went the wrong way with it. I didn't double it, I halved it. So anyway, so there's one petal, and I know that this is, again, the petals are going to be symmetrical, so probably something like that. But I don't really care, and I'll tell you why in a second. So now look at these 2 functions. These are almost the same thing. This was 2 times the sine of 3 theta. This is 5 times the sine of 3 theta. So where this was 1 times 2, this is going to be 1 times 5 in the same angle. But sine is still 0 at the same time. So the second polar equation looks something like that. Okay, and so what is the total area between them? Well, they're wanting us to find this area plus this area plus this area. So all I did, and this is why I'm being kind of sloppy with the rest of the graph, is I said, well, this area, and this area should all be equal. So I'm going to say I have 3 of these areas, and then I'm actually only going to solve for 1. because I multiplied it by 3. I know there's 3 of them. Okay, and in this one, it looks like I will have to subtract also. So I could find the area of all of this in red. And again, I know the graphs are a pain, but the nice thing about the graphs is you also probably have the angles you need. This started at 0 radians and finished making one petal at pi over 3 radians. And same with this guy, 0 to pi over 3. Now, subtraction, the order matters here. So make sure you use the big one first. If I find the area of this big one, that's too much, come back and then subtract how much area is missing, this one. So the big one is 5 sine of 3 theta. The small one is 2 sine of 3 theta. And I didn't type that in yet. But I hope it works. So give me a second, I'll type it in and we'll double check. Make sure there's nothing else we need to look at. Oops. Okay. All of that, my calculator getting 16.493, and that matches up with what they have. So that's one possible approach. Again, I knew that there was 3 of these petals. I just chose to find this area that they shared in quadrant 1 and multiplied it by 3. If for some reason you'd rather find the same area in this petal in quadrant 2 or in this petal in the bottom and multiply it by 3, it's fine too. There's not like, a lot of these have more than one correct path, so I'm just trying to share with you what works for me. Okay, anything else about number 1 while it's there?